So we're still talking about improper integrals, and now we're talking about improper integrals of type 2. Right? So what is an improper integral of type 2? Well, in this case we have some function f defined on an interval a, b into r, and when this function is continuous on the whole interval a, b, then we can use the fundamental theorem of calculus to calculate the definite integral from a to b. Okay. But now, here we have three cases where the function isn't continuous on the whole interval a, b. Okay. So, in the first case, we have f is continuous except here at the one endpoint a. Right. So now, because we can't use the fundamental theorem of calculus to calculate this integral, right, we have to make another plan. And the plan we make is to note that, well, no matter which t I pick between a and b, right, this integral from t to b, right, that's just a usual definite integral that we can calculate with the fundamental theorem, right, because the function is continuous here, it's just not continuous at a. Right. So what we do is, well, we calculate this integral, and then we take a limit. Yeah. So we say this is equal to limit, right, and now we're letting t tend to a, and note that we're letting t tend to a from the positive side, right, because we take t here, bigger than a. Right. Integral from t to b f of x dx. Right. So again, you can think of this integral from t to a is giving you that area. Right. And now we're letting t tend to a. Right. So notice that this limit may not exist. Right? So we say that this integral is convergent if that limit exists. Again, as a finite number. Right? So if this limit exists as a finite number, then this integral is convergent, and the value of the integral is equal to this limit. And so if the integral is not convergent, then we call it divergent. Right? Now the second case is very similar to the first. Right? Now our function is discontinuous at the other endpoint b. Right? So we're going to do the same thing. Right? Calculate the integral from a to t for some t between a and b. So we take our t there. Right. So then that integral from a to t, you can sort of think of as that area. Right. And then we take the limit as t tends to b. Right. So now we say integral a to b f of x dx is the limit as t tends to b, and this time we tend to be from the negative side, right, because we take t here, less than b. Right? So we're going to let t tend to b. Right? So if this limit exists as a finite number, right, then our integral is convergent. Right. And now, the last case, right, is when we have a discontinuity somewhere between a and b. Right. So now in this case, again, we have to split up the integral into two pieces. Right. So if we let I be integral from a to b f of x dx, Right, and we have to split it up into two pieces. Right, I1 will be, say, integral from A to C, right, and I2 will be integral from C to B, f of x dx. Right. So note that because your function f is discontinuous at C, both these integrals are improper integrals, right? And if both of these are convergent, right, so then we say that I is convergent, right, our big integral. Okay. So let's look at our three cases. Right? First case, when we have a discontinuity at the left endpoint of the interval at A, then our integral from A to B, we express it as the limit as t goes to A from the positive side. It's the integral from t to B. Right? And this integral is convergent if the limit exists as a finite number, right? Like 2 or 5 or 7 over 10. Right? Our second case, right, that's when we have a discontinuity at B, the right endpoint of the interval. And then again, in this case, we have to express our integral from A to B as a limit. Right? This time the limit as t goes to B from the negative side. And if that limit exists as a finite number, right, then our integral is convergent. The last case is when we have a discontinuity here somewhere in the middle of your interval AB. Right, and you have to split your integral up into two pieces. Integral from A to C, and integral from C to B. Right, and you treat both those as improper integrals. Right, and if they are both convergent, then your integral I is convergent. Right, so if one of them or both of them are divergent, right, then your integral I is also divergent. Right, so we look at a couple of examples of how to calculate these kinds of integrals.